Good morning, this is your Stat Sensei, Mr. Spensei, and this is another simulation, and this is going to be 4-H project raising chickens. So, as a 4-H project, Billy is raising chickens. He feeds and waters them every day and collects the eggs every other day, selling them to people in the neighborhood. He's found that each hen's nest will contain from 0 to 2 eggs. This is going to be important because we can go, oh, 0 to 2 eggs, that means it could be 0 eggs, 1 egg, or it could be 2 eggs. We don't know what. Based on past experience, he estimates that there'll be no eggs in 10%. So 0 eggs 10% of the time, 1 egg in 30%, and 2 eggs in 60%. Conduct a 3 trial simulation. All right, so we're going to have to do this 3 times and to estimate how many eggs nest Billy will have to visit to collect a dozen eggs. All right, so we have some important information here. First off, 10%, 30%, and 60%. If I divide those by 100, 10 over 100, that reduces, all right, to 1/10. If I go if I take 60 out of 100, that reduces. So all these reduce, and because they reduce to one digit numbers, I can use 1 digit numbers. Could use 2 digit, but it takes a lot longer to run. So the question is, how many nests to check to get 1 dozen eggs? If I end up with 11 eggs, it's not enough. If I have 12 eggs, I have plenty. I can stop. If it goes one over, because I don't get exactly 12, that's fine. But I have to have at least 12 eggs. So we stop as soon as we get 12 eggs. So success, at least a dozen eggs. What are we going to do? We're going to keep checking nest. How many trials are we going to run? 3. And because we are working with percents, anytime we work with percents, duplicates are going to be allowed. All right. Repeats are going to be allowed. And in this case, we don't have any skips because when we add up 10 plus 30 plus 60, we get 100%. So in this case, there's no skips. So 0 eggs, that occurs 10% of the time. So one number. 2 eggs, 1 egg, that occurs 30%, so I need 3 numbers. So if I made my number line, and I'll just go ahead and do this, I actually have, so because this will help make more sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll put 0 up here. Well, 10%, that's one number. Then I have 3 numbers, 2, 3, 4. That's 30% because that's 3 out of 10. And this right here, 5, 6, 7, 8, 9, that's 6 out of 10, which is 30%, 60%. So there's 60%, here's 30%, and this right here represents 10%. So that's the way we're going to assign the numbers. So beginning from left to right, because we always begin from left to right, because that's where we read, I would select 1 digit numbers until I have at least a dozen eggs. I count the number of 1 digit numbers until the total of at least a dozen eggs have been selected. I'm going to do this 3 times, so 3 trial simulation, and take the average. And that'll tell me how many nests I have to check in order to get a dozen eggs. All right, since we're only running 3 trials, we have plenty of rows, so we can start over. So we can start a new trial on each row. So on our first trial, the first nest had 2 eggs. The second nest had 2 eggs. The next one had 1. The next one had 1. By the way, I have a repeat, but remember, we're working with percentages, so repeats are allowed, so this isn't a problem. Then I have a 1, then I have a 2, and then I have a 1. So in this case, when I add that up, that's 2, 4, 5, 6, 7, 8, 9, 10, 11, 12 eggs, and I had to check 1, 2, 3, 4, 5, 6, 7, 8 nests. So on the first trial, we had to check 8 nests in order to get 12 eggs. Going to the second trial, which we get to start on a new row, the 6, that's a 2 eggs, 2 eggs. The 3 is a 1 egg. The 6 is a 2 egg. And remember, repeats are allowed because we're working with percentages. We have 2 eggs. 0, even though it says 0, remember we assigned that as 2 eggs, and 4 is 1. In this case, we have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we tried 1, 2, 3, 4, 5, 6, 7 nests. So to get to 12 eggs, we tried 7 nests. On the next one, we said, okay, 6 is 2 eggs, 0 is 2 eggs, 0 is 2 eggs. We tried this one. A 2 is a 1 egg because it's a 2 to 4, 1 egg. A 9 is a 2 egg, and 8 is 2 egg. And once again, 2, 4, 6, 7, 8, 9, 10, 11, 12. We tried 12 nests in order to get, we tried 7 nests in order to get the 12 eggs. All right. So in our table, 8 nest, 7 nests, 7 nests, add that up, and we get 22. 22 divided by 3 is 7.3. So based on the simulation above, in the long run, on average, we'd expect to check 7.3 nests in order to collect at least a dozen eggs. Once again, if it's in red, it's coming straight off of your recipe card. This is your sentence stem, and the part in blue is what you actually calculated when you ran your test or ran your simulation. All right, I appreciate you watching, and I look forward to seeing you on the next one. Thank you.